Clean out the burette with some water. Swish it around a little, then pour it out. Repeat this process with your known concentration solution. Then, pour around 30 milliliters of your known concentration solution into the burette. Make sure to record the initial volume to 2 decimal points. Next, clean out the pipette with some water. Swish it around a little and pour it out. Repeat this process with your unknown concentration solution. Next, fill the pipette up to the line that marks the 25 milliliter line. Make sure the bottom of the meniscus lines up with the 25 milliliter line. Pour this into the conical flask slowly. Using the wheel at the top of the pipette, make sure to get all of the solution, including the blowout. Then, add 3 to 5 drops of your chosen indicator and give it another swish. Next, place a white tile on the stand and place the conical flask on top of it. This makes it easier to see the color change against the white background. Fix the burette to the clamp, making sure the tip of the burette is in line with the top of the flask.
You can let the solution in the burette free flow into the conical flask, stopping at the color change point, also known as the end point. This first trial should be an estimate. Slow down to drops when you want to find this equivalence point. Then you want to keep repeating the whole process till at least 3 of your trials are within 2/10 of each other. This means that you found a concordant equivalence point. The equivalence point is where the moles of your base equal the moles of your acid. And make sure to record your final volume to calculate the difference later. Use your 3 concordant trials to find your average milliliters of known solution required to neutralize the unknown solution. A sample calculation will be shown with patient 1, where the HCl in patient 1's stomach acid neutralizes at 15.15 ml of 0.5 molar NaOH. The following equation is used, where concentration of acid times volume of acid equals concentration of base times volume of base. Therefore, 0.5 moles of NaOH times 15.15 mL of NaOH equals X concentration of HCl times 25 mL of HCl. Dividing both sides by 25 isolates X, and solving for the left side gives 0.303. Therefore, X is around 0.3 moles. Taking the negative log of this gives the pH, and the negative log of 0.303 is around 0.5. We found the concentration and pH values for all 3 patients, and when linked with the symptoms, we believe that patient 1 is patient letter P who has hyperacidity, patient 2 is patient letter C with obstructive jaundice, and patient 3 is patient letter S with bacillary dysentery.